Dear students, welcome to Statics and Dynamics with me, Dr. Loay Al-Zube, and thank you for tuning in to this video. We are starting a new lecture, this lecture 6 on our online discussion of the content. And in this lecture, we're going to learn about the dot product and its applications, actually. So before we start into this, you remember from the previous lecture, we talked about the position vectors and how can we find them and represent them in Cartesian coordinate systems, and how can we use the position vector in to calculate the unit vector of the direction, and then use that unit vector if you want to represent a force directed along that particular line or position vector, how to represent the force. And also, so those are very important concepts. We are still talking about the basics of force vectors and how vector manipulations, and we're going to introduce something important because there is a big challenge when we deal with vectors in 3 dimensions, and we would like to see how we can solve the challenge. So occasionally in statics, one has to find the angle between 2 lines, right? So if you're looking in the street and you have this traffic light and there's these supporting lines and or the light tower, whatever, and if you're looking at one of the transmission towers for the cellular services, the mobile services, so we want to see that we want to find angles between different 2 lines. So it's easy if you did it in 2 dimensions, or if you want to find it in 2D, but it's very challenging when it comes to 3 dimensions. And the other challenge is that if you want to find the components of a force parallel and perpendicular to a particular line. And keep in mind that we are talking about 3 dimensions now, so we might want to find the projections, which mean the components of a force along a line that does not necessarily is one of the axes, X, Y, or Z. And also the line or the lines that we're trying to find the projection on, they don't necessarily need to be orthogonal to the force. So it's a general idea and a general concept that we need to understand. Those are big challenges, but there is a solution for them, which is the dot product. And that's what we're going to be presenting and talking about in this lecture, in lecture 6. So we will learn about what the dot product is and how to determine the angle between 2 vectors, and how to find the projection of a vector along a specific line, right? So the dot product, which defines a particular method of multiplying 2 vectors, in between quotations, multiplication. So what does that mean? And it can be used actually to solve the challenges that we talked about. So let's dig into this challenge and see how can actually the dot product be used here. So let me present first some of the challenges and what do I mean by finding the angles and the projections. So the first thing, let's talk about the angles between 2 vectors. So if you look at this image here, you can see that you have these 2 cables that they are supporting, a shade or whatever structure on a wall or in a building. So if you know the physical location of the 4 cable ends, so these 2 here, 1 and 2, and then it's 1 and 2. So there's 4 points. It's actually 3 because they're attached to the same, very close to the same point here. So if you know the physical locations, the coordinates of these points, of the cables, how can you calculate the angle between the cables? So how can I get this angle in 3 dimensions in an easy way? I don't want to go to do projections on the X, Y, and Z, and it will be a lot of work. So is there a way to do that? And actually there is, which is the dot product, and we'll talk about that. So just in a quick overview, you can find the position vector of this one and that one. You can find the unit vectors of the both, and because we learned how to do this before, and then you can do the dot product and you find the angles. We'll talk about this more. So this is about the angles. I'm just demonstrating what is the challenge. Now for the what about the projection of vectors? So let's say if you have 2 forces and you want, or 2 of a vector and a force, and you want to find the projection of one force along that position vector. So how can we do this? So to represent this in an example, you can see that you have this subject who's pulling on the wrench here, and imagine, make sure, be sure that we are talking about, see the angles here. So we have, these are shaded angles, are projection angles. So I have 45 tilted with the let's say the x y plane, and then I have going up, my force of 80 newton is 30 degree with also the in the y z plane. So it's not 90 degrees and not perpendicular. So the force applied to the wrench at point A, what component of it actually helps turn the bolt? So is it the one that is along the z-axis, the one along the x-axis, or the one along the y-axis? Which one does actually help in turning the bolt? And we want to find that. And this is where projections are important, to project the force on a particular line. Again, so let me, the answer for this is the dot product, so which define a particular method of multiplying two vectors and can be used to solve the challenge, and it can find us the projection on a particular line. So I will stop here in this video for this introduction, and in the following video of this lecture I'm going to define the dot product and see how can we use it in finding the angle and in finding the projections. Thank you for watching. Until next video. Bye.